So welcome back, guys. So in this lecture we will discuss what is about positive real function. Okay. So I already said that for network synthesis, this is the network synthesis, we have to find the circuit if for the circuit there will be given a positive real function. So the positive real function is describe the circuit. Okay. That is, positive real function may be represented as h of s. So this positive real function h of s may be a driving point impedance, that is Zs, or a driving point admittance, that is y of s. Okay, what is this driving point impedance and admittance? So if you have a circuit, for example, we have a resistor and suppose capacitor I take. Okay. So the Laplace of this capacitor is what? 1 by Cs. The Laplace of this resistor is R. So to find the impedance, that is Z of S, is what? Z of S is equal to R into 1 by Cs divided by R plus 1 by Cs. You know this. So by calculating this, make Cs common. So you will get R by RCS plus 1. So if you take RC common, you will get 1 by C by S plus 1 by RC. Okay. So you obtained Z of S, that is Z of S equal to 1 by C divided by S plus 1 by RC. That means this Z of S is a real function. Okay. So you will be given a real function, that is h of s, in the name of h of s, that is Z of s, or y of s, that is impedance function or admittance function. It is in the form of S domain. So by using a different techniques, that is you have a Foster form, Koya form. So in that techniques, to find that forms, we use this function to get this circuit. Okay. So until it is for this circuit, you draw this Z of s. Now this Z of s will be given and you need to find this circuit, that is synthesis. So what is about Z of h of s in general? The standard representation of positive real function in general given by h of s, that is h of s equal to a0 s power n plus a1 s power n minus 1 plus so on up to a of n minus 1 s plus a of n by b0 s power n plus b1 s power n minus 1 plus so on up to bm minus 1 s plus bm. Okay, this is the positive real function in general you will be given. So in the form of, it may be impedance or admittance. Okay, so this positive real function has, if the function which is said to be a positive real function, it should be satisfy few conditions. Okay, the conditions were, so this is the positive real function you will be given. Okay, so P of s, that is having a numerator and the denominator. So in the S domain, they will have this P of s will have 1 degree and the Q of s will have another degree. So if this function is said to be a positive real function, this function need to satisfy few conditions. That is, if P of s will be real, that is this will be real if S is real, that is the Laplace of this S is real. Okay, and if Q of s is a Hurwitz polynomial. So we'll find about what is Hurwitz polynomial, that is Q of s, and if h of s has poles on real axis. Okay, if h of s has poles on the real axis, the poles must be simple and the residues must be real and positive. Okay, that means it should have a left half s plane. The poles should be, the poles means they should be left half s plane. So the poles has a real axis, the poles must be simple and residues must be real and positive. and real of h of jk, that is, if you substitute s equal to j, it should be in the mode of it should be greater than equal to 0 for all values of omega. Okay, what are the values substitute the omega? The value of h of s should be greater than 0. So these are the few conditions of positive real function to be satisfied. And we have properties also of this positive real function. The properties were so these are the properties. Okay, the both p of s, q of s are Hurwitz polynomial, and they may contain factors of the form s square, so omega square. So they should be contained the second order form s square omega square. So both p of s and q of s are Hurwitz polynomials. If they are Hurwitz polynomial, we want to know what is Hurwitz polynomial, and they may contain factors of form s square plus omega square. The second order means you will have a capacitor and inductor thing here. Okay, and then the second other property is the highest and lowest powers of p of s, q of s differ by unity. That means the p of s, q of s, you should not have any one differ by some unit. Okay, they will be differ by order of unit. If h of s is positive real function, okay, the reciprocal of h of s must be a positive. So the reciprocal of, if h of s is positive real function, then the reciprocal of that h of s must be a positive real function. Okay, and then the sum of positive real function is a positive real function. That means if two real functions are added, then the obtained is also a positive real function. Okay, the obtained is also a positive real function, but differ of positive real function is not a positive real function. So the sum of positive real function is a positive real function, and the difference of positive real function is not a positive real function. Okay, these are the few properties of positive real function. Okay, so in the next class we will deal about what is Hurwitz polynomial, and we will also go to ELC immutance function. And thank you guys.